In our lesson today, we're going to be working with literal equations. Literal equations are equations where most, if not all, of the terms in the equation are going to be variables. When working with literal equations, your task will be to solve for one of the variables in terms of the other variables. The question will state which variable you are to find. Concentrate on that variable and treat all of the other variables as constants. Just pretend that the other variables are numbers. Okay? The methods used to solve literal equations are the same as the methods you have already learned to solve equations. And so if we look at our first set of examples here, in example number 1, it says solve each equation below for x. The equation on the left says 5x plus 3 equals 33. The equation on the right says ax plus b equals c. This equation on the left is just a basic two-step equation that you should be very comfortable solving. Notice that the literal equation, where every single term is a variable, is structured the same way as the two-step equation. Okay, here we have 5 multiplied by x. Here we have a multiplied by x. Here we're adding 3. Here we're adding b. And over here, the answer after the equal sign is 33, while over here it's c. Both of these represent two-step equations, so it's going to take 2 steps for us to isolate the variable. Let's start with the equation on the left that we're comfortable solving. First thing we're going to do is isolate the variable term 5x. In order to do that, we're going to subtract 3 on each side. All right. Following a similar process over here on the right with the literal equation, we have to isolate this term ax because it's the term that has x in it. So we're going to start by subtracting b on each side of the equation. Okay, for the equation on the left, when we subtract 3 on each side, we get 5x equals 33. All right, and on the equation on the right, we're going to have ax, all right, and then b minus b is 0, so they have been simplified there, equals c minus b. 33 minus 3 is 30. That should say 30 right there, excuse me. 33 minus 3 is 30. So here we're going to do c minus b. Well, that's just c minus b. Okay, so ax equals c minus b. Now back to the equation on the left. In order to isolate the x term here, we're going to divide each side by 5. And so following a similar process over here on the right, in order to isolate the x term, we're going to divide each side by a. All right. Going back to the equation on the left, 5x divided by 5 is 1x, or just x. 30 divided by 5, of course, is 6. And with the equation here on the left, or on the right rather, ax divided by a is going to be our 1x that we're looking for, and it's going to be equal to the difference of c minus b, all divided by a. So we have just solved the literal equation for x in terms of the equations, variables rather, a, b, and c. Okay, so I still have variables in every part of my answer here, but the variable x has been isolated in terms of the other variables in the problem. So in our previous example, we had the equation on the left where we could calculate the exact value of x, but in the equation on the right, we had to leave the answer for x in terms of the other variables. It's going to be a very similar process here for example number 2. We're once again going to solve each equation below for x. On the left, we have x plus 5 divided by 2 minus 7 equals 3. And with the equation on the right, x plus a divided by b minus c equals d. Once again, notice that these two equations are structured in the same way. So I'm going to start with the equation on the left. I'm going to follow my steps for the equation on the left to try to isolate x for the equation on the right. So looking at this equation here on the left, x plus 5 divided by 2 minus 7 equals 3. Our goal again is to figure out what x is, isolate x. And this term right here, x plus 5 divided by 2, is the term that has the variable in it. So we have to isolate this first, which means we're going to deal with this constant -7. So I'm going to start by adding 7 to each side of the equation. And when I do that, I'm going to get x plus 5 divided by 2 equals 10. Moving over to the literal equation, same idea here. I have to isolate this term because it has the variable x in it. And so I'm going to start by adding c to each side of the equation. So when I do that on each side, I'm going to have x plus a divided by b equals d plus c or c plus d. Addition is commutative, so either one of those is fine. Moving back to the equation on the left. All right, so again, I've got to try to figure out how I can isolate this variable x right here. The numerator x plus 5 is being divided by 2, so I'm going to multiply both sides by 2 on this equation. Those 2's are going to simplify on the left, leaving us with x plus 5, and that's going to equal 20. Over here with the literal equation, once again, the numerator x plus a is being divided by b, so I'm going to multiply both sides by b. And when I do that on the right-hand side, this whole expression c plus d is going to have to get multiplied by the variable b. These b's on the left are going to simplify to make 1, leaving us with x plus a equal to b times c plus d written in parentheses. Now there's only one thing left to do to isolate x. On the left, we're just going to subtract 5 from each side so that x is 15. And on the literal equation, we're going to subtract a from each side. A minus a is nothing, leaving us with x. And that's going to equal b multiplied by c plus d in parentheses minus the value of a. And that is your literal equation solved for x in terms of the other variables. X equals b times the quantity c plus d minus a. In example 3, we're going to solve the equation below for x in terms of the other variables. The other variables we have here are h and k. Notice in this equation that we do have some numbers. We have a 2 right there. We have an 8 right there. Okay, so we're going to just treat this algebraically just as we would any normal equation. We have to try to isolate that variable x right there. So we're going to first isolate this whole term because it's the one that has x in it. So we're going to start by subtracting k from each side. Minus k, minus k. When we subtract k from each side, 2 multiplied by x minus h equals 8 minus k. All right. The next thing that I'm going to do, I'm going to isolate the x minus h. Right now, x minus h is being multiplied by 2, so I'm going to divide that by 2. And if I divide by 2 on the left, I'm going to divide by 2 on the right. Now I have to divide everything by 2 on the right-hand side. So looking here on the left-hand side, 2 divided by 2, that makes 1, leaving us with x minus h. And on the right, 8 divided by 2 is 4 minus k divided by 2. X minus h equals 4 minus k divided by 2. There's only one thing left to do to get x all alone, and that would be to add h to each side of the equation. And so when we do that, x is equal to 4 minus k divided by 2 plus h. And so we have successfully isolated the variable x in terms of the variables k and h, and we still have some numbers in the equation, but that's as simplified as this gets. X equals 4 minus k divided by 2 plus h. In our next example, the perimeter of a rectangle can be found using the following equation. P equals 2L plus 2W. P, of course, is the perimeter, L is the length, and W is the width. We are going to rearrange this formula so that it's solved for the width W. So we want to get this W all by itself. So let's start by writing the equation again. P equals 2L plus 2W. All right. Again, we've got to get W all alone. So the first thing I'm going to do is isolate this entire term, which means I'm going to start by subtracting 2L from each side. When you subtract 2L from each side, on the left, we're going to have P minus 2L equals, on the right, well, 2L minus 2L is 0, so that leaves us with just 2W. Now, in order to isolate the variable W, we're going to divide by 2, which again, on the left means I'm going to divide everything by 2. Okay, and so when I do that, well, again, on the right, that's the easy part. 2W divided by 2 is W. And on the left, P divided by 2 is just that, P divided by 2, minus 2L divided by 2 is just L, or 1L. So we've now isolated the variable W in terms of the other variables in the equation. W equals P divided by 2 minus L. Okay. Now what we're going to do with that, all right, this equation, again, we can use this to figure out the width of a rectangle if we know the perimeter and length. They've told us that a garden has a perimeter of 244 feet and a length of 85 feet. We're going to use this formula in order to find out what the width is and then calculate the area of the garden as well. So in my space underneath, I'm going to start by writing my isolated literal equation for W. W equals P divided by 2 minus L. And now I'm going to substitute in the values that were given. All right, the perimeter was 244 feet divided by 2 minus the length was 85 feet. And when I figure out what all this is, that's going to be the width of the rectangle. Following order of operations, I'm going to divide 244 by 2. Well, 244 divided by 2, W equals 122 minus 85. And now to figure out what the width is, I'm just going to subtract 122 and 85. W equals 37 feet. The width of the rectangle is 37 feet. Now I'm going to calculate the area of that garden. Remember that the area of a garden is the base times the height, or the length times the width. And in this problem, they told me the length was 85. We just found out that the width is 37. So the area is 85 times 37, which is going to be 3,145 square feet. Remember, with area that we need to square the units. Okay, so we can have a picture, something like that, of our garden, where we know that this is going to be the length measurement of 85 feet, and this is going to be the width of 37 feet. And again, 85 plus 37 plus 85 plus 37 is 244 for the width, or for the perimeter rather. So this is what our picture would look like for this example. In our next equation, set of equations, we have on the left 8x plus 1 equals 5x plus 22. And on the literal equation on the right, ax plus b equals cx plus d. All right, again, these two equations are structured similarly, but this is a little bit of a tricky problem because notice in each equation, the variable x, which we're trying to figure out, we're trying to isolate, appears on both sides of the equation. All right, so once again, we're going to follow our algebra steps for this equation on the left because we're comfortable solving an equation like this in order to help us isolate x with the literal equation on the right. So let's start over here. 8x plus 1 equals 5x plus 22. We want to get the x's all on one side, so I'm going to start by subtracting the 5x from each side. And when I do that, 8x minus 5x is 3x, plus 1 equals 5x minus 5x is 0, so we're left with 22. So we started by subtracting the 5x from each side of the equation. Let's do a similar process over here. I need all the x's on one side. So I'm going to subtract cx from each side of this equation. All right. So ax minus cx is just that, ax minus cx plus b equals cx minus cx is 0, so we're left with the variable d on the right-hand side. Okay, going back over here to this equation on the left, now we're going to isolate that 3x. So we're going to subtract 1 from each side. 3x is 21. And following a similar pattern over here, we're going to isolate each of these terms here that has x in it. So we're going to subtract that b from each side. Ax minus cx now is going to equal d minus b. With the equation on the left, notice that there's only one x in this equation, so it's going to be very easy for us to isolate that x. But over here with the literal equation, notice there's still two x's, all right? There's an ax minus a cx. The variable x shows up twice. I want the variable x to show up only once in this equation, just like it shows up only once over here. And what I notice is that each term in this expression here on the left-hand side has the variable x in it. When each term has the variable x in it, I'm able to factor that out. So I'm going to rewrite that as x multiplied by, well, ax divided by x is just a, minus cx divided by x is just c. So x times a minus c equals d minus b. And now there's only one x in the equation, just like there's only one x over here. So with this equation on the left, we would simply just divide each side by 3 to get x equals 7. Now to isolate this x, we're going to divide each side by this expression a minus c. Divide each side by a minus c. All right. This a minus c with this a minus c, they simplify to make 1, leaving you with just x. And it equals, on the right-hand side, d minus b in the numerator divided by a minus c in the denominator. And we have just solved x in terms of the variables a, b, c, and d. So keep in mind that when a variable shows up in each part of an expression, you can factor that variable out in order to make it show up just once. Ax minus cx is the same as x times a minus c. In example number 6, we have that the equation shown below shows how you can calculate the future value of an investment. V equals P plus PRT. We're going to rearrange this equation so that it is solved for just the variable P. So in the end, it's going to look something like P equals, and on this side of the equation, the variable P isn't going to be there anymore. All right, there's only going to be one variable P, and it's going to be on one side of the equation. Notice in this equation, V equals P plus PRT, P shows up twice. And this is similar to the first or the previous example that we had just done. When the variable shows up in each part of the expression here on the right-hand side, you can factor that out. All right, so I'm going to rewrite this as V equals P times, and now I have to figure out what's going to go in the parentheses here. Well, P divided by P is going to be 1 plus PRT divided by P is just going to be RT. So this equation, V equals P plus PRT, is the same as V equals P times 1 plus RT. If you were to distribute this P to each term in the parentheses, you would get the original equation back. Now the variable P only shows up once in the equation, and it's going to be very easy for us to isolate the variable P. P is multiplying 1 plus RT, so to isolate P, we're going to divide each side of the equation by 1 plus RT. Divide each side by 1 plus RT. When you do that on this right-hand side, 1 plus RT divided by 1 plus RT, that simplifies to make 1, leaving you with just the variable P. And it's going to be equal to, on the left-hand side, V in the numerator divided by 1 plus RT. And there it is. We have successfully solved this equation for the variable P in terms of the other variables. P equals V divided by 1 plus RT. V divided by 1 plus RT.